you clicked into this video, that means you, like me, are an avid skincare enthusiast who enjoys researching the chemistry behind different skincare ingredients, loves combining education with video production, and does dance in their free time? Okay, maybe you're not exactly like me, but welcome to the first video of my series where I teach you about what I've learned regarding the chemistry behind skincare. So today, let's begin with a hot topic, and what I'm sure you all are here to learn more about: the chemistry behind sunscreen and its impact on coral reefs. Plus, stay to the end to learn what you can do about it. Let's begin with understanding the chemistry behind sunscreen. Ultimately, the goal of a sunscreen is to protect you from UVA and UVB rays, which are forms of natural energy that the sun emits. Their wavelengths are super duper small, so you wouldn't be able to see it with your naked eye, but they can cause a lot of damage. Without proper protection, these rays penetrate into your skin and damage the DNA in your skin cells. Repeated exposure to UVA and UVB rays over time increases your risk of developing skin cancer and can cause premature aging. That's where sunscreen comes in. But what's responsible for sunscreen's magical ability to protect you from the sun? All sunscreens contain active ingredients from one of two categories. The first kind is inorganic, synonymous with physical or mineral UV filters. This includes zinc oxide and titanium dioxide. Inorganic UV filters block UV rays by scattering and reflecting light. The second kind of UV filter is called organic, aka chemical UV filters. These work by absorbing the harmful UV rays and then re-emitting the energy in a less harmful form. One specific UV filter may ring a bell, and that is oxybenzone. It's an ingredient that is thrown around in the discussion of sunscreen and coral reefs, so let's delve a bit deeper into its chemistry and its effect on coral. Oxybenzone falls under the organic or chemical UV filter category. The OH group in oxybenzone's molecular structure grants it the ability to absorb UVA and UVB rays. The absorption of this photon energy excites the electrons in oxybenzone. Once the electrons return to ground state, which is the lowest and normally occupied energy level of an electron, the absorbed energy emits in longer wavelengths. This decreases skin penetration of UV rays and reduces the harm significantly. Now that we understand a bit more about oxybenzone, let's get into its effects on coral by looking at a couple of studies. Researchers at Wageningen University conducted an experiment on 2 species of coral and their survival rate after being exposed to oxybenzone and elevated temperatures. They concluded that the effect of oxybenzone alone was already statistically significant, but the added negative effect of high water temperature caused one species of coral to completely die out and the second to experience bleaching. In another 2017 FDA study, a sea anemone and mushroom coral species were exposed to levels of oxybenzone present in reef zones. After 17 days, all of the sea anemones were dead. Clearly, exposure to oxybenzone is directly related to the death and bleaching of corals. Let's see how this bleaching occurs. As for how oxybenzone bleaches coral, it's because the compound is metabolized by coral under sunlight. This metabolized oxybenzone, known as oxybenzone glucoside conjugate, can still absorb light, but now it does not have a way to release the energy as heat. It is now a toxic compound that essentially does the opposite of a sunscreen. It causes damage to cells and tissue. Another effect of oxybenzone on coral reefs is that it damages coral reproductive success by deforming coral larvae. It surely doesn't help that an estimate of up to 20,000 tons of sunscreen end up in coastal waters through people who lather on sunscreen before going swimming at the beach. This causes coral reefs to come in contact with alarming amounts of oxybenzone and other harmful sunscreen ingredients. And there have already been several mass bleaching events since the 1980s, and incidences have since been occurring more frequently, such as in 1998, 2002, and 2016, with the most recent widespread bleaching event only occurring in 2020. Why does coral bleaching and death even matter? Well, coral reefs support some of the most diverse ecosystems on Earth. They provide shelter for the reproduction and protection of coral organisms, which keeps the food chain in balance. They are also responsible for absorbing the force of waves during storms, which protects coastal communities. And once these corals die, reefs rarely come back, so the damage would be irreversible. With all the research backing up certain UV filters' harmful effect on corals, as well as the recognition of the importance of coral health, it's no surprise that places like Hawaii, US Virgin Islands, and Palau, which have numerous coastal waters, have begun implementing bans on certain sunscreens, especially ones widely researched like Oxybenzone. And the sunscreen market has adapted to this growing concern of sunscreens harming coral reefs by marketing products with phrases like reef safe or oxybenzone free, such as this one that I have at home. I'd like to leave you with some solutions that you can implement on the beach in order to help this issue of coral bleaching and death. First is to swap out your common household chemical sunscreen for a mineral sunscreen. Look for the ingredients zinc oxide and titanium dioxide in the ingredient list. Another option is to opt for clothing that have UV protection. This means sun hats, sunglasses, sun shirts, leggings, and an umbrella. They're all good choices, but no matter what, not protecting yourself from the sun at all is never an option. At the end of the day, we want to find a middle ground between protecting yourself and protecting the environment. Have fun out there, and I'll see you in the next video.